All right, for our next order of business, we are going to be talking about data and statistics. So, this is one of those topics that you hear a lot. You hear it all the time when you're watching sports. You know, they're giving statistics on those players all the time because they want to give you some information about how good of a player he is, how many points he scores, what's his batting average, all those kinds of things. So, based on what's happened so far in the season, then what are the stats that go along with that person? So you hear it on the news all the time. All kinds of research that gets done and all this data that's collected, and then what kind of conclusions can we draw from that data? And then that's what they share with you. So you don't actually have to necessarily go through every piece of data to learn something from it, but you can learn something from the conclusions that other people have drawn. So that's what we're going to be talking about. And the first topic is probably one of the most applicable, in my opinion, and that is measures of central tendency. These are basically summary numbers that describe a whole group of data. And there's three main types that we'll talk about. That's the mean, the median, and the mode. And at least one of those you should have heard of. So let's take a look at what we have here. It says, suppose there was a math test yesterday and miraculously they're already graded. Typically, the first question asked in class is, so how did we do? If your math teacher responded by reading everyone's name and their grade out loud in class, you would either be extremely bored or embarrassed that your grade was just broadcast to the entire class. So, how do we answer this question minus the boredom and the embarrassment? Rather than me listing off every single person's grade, you are looking for a summary. What's a quick overview of how the entire class did to help put your mind at ease on how you did? So measures of central tendency would be what we would use in this particular situation. So let's talk about mean for a second. The mean is also known as the average. And the way we find that is we take the sum of all the values and then divide by the number of values you have. So if there are 10 numbers, we would add up each of those 10 numbers to get our total sum. And then whatever that sum is, we divide by 10. That's the one you're probably familiar with. The median is a little bit different. This is the middle value of an ordered set of data. So the key here is all of your data has to be put in order. So you need to put it in order from least to highest, and then you can start determining what the median is. Now, two different things could possibly happen. One of them is you have an odd number of values, so that means there's only one number sitting in the middle because everything partnered up except for that one value. So that's the easy one. If there's an even number of values, then you have to take the two numbers that are in the middle, because they would be partners, and then find their average or their mean. So we'd find the average of those two, and then that number would be the median. So it's possible that your median isn't even one of the numbers in the set of data. You might have heard of the word median when you're talking about the highway or a street. Those big stretches of grass or shrubs or trees or whatever they have that separates one direction of traffic from the other direction of traffic is called the median. If you go out on Lebanon Road in front of the school, they have little curbed off areas that have some nice grass and some mulch and some bushes and a couple trees here and there to make it look pretty. It physically sits in the middle, separating one half of the road from the other half of the road. It's called the median. Or out on 275, you could go east or you can go west as soon as you get out here on off of the Loveland um, exit. Then there's this big, huge stretch of grass in between your two directions of traffic. That's also known as the median. So it physically sits in between the two. And then there's the mode, and that's the value that occurs the most often. Mode, most. See, that's a good way to remember that. Mode, most. Whichever number is there the most. And if there's a tie and there are two numbers or three numbers that are there the same amount and they are the highest number of times listed, then you would have more than one mode. So that's very possible. So for mean, you'll have one value. For median, you'll have one value. Mode, you could have no mode, one mode, two modes, three modes. It depends on the situation. All right, let's take a look at this in more detail. I'm going to cover up here for a second because this is the second time I've done this because the first time messed up. So it says provided below are the actual scores from a math test on their last test. The scores are the percentages earned by each member of the class. Find the mean, median, and mode for that set of data. So let me erase this here for you so we can see these clearly. So here are our scores. Okay, so here's all the data that we have. I decided to go ahead and erase all this stuff, so just so it wasn't confusing. All right, now to find the mean, if you remember, it was the average. So that means we're going to add up all of these values, and I will tell you there are 19 pieces of information, and then we're going to divide by how many we have. So why don't you pause the video right now and add up your numbers, and I want you to, in this box, make sure you write down the sum and then what you're dividing by. So I want to see that division problem, and then you can go ahead and divide and round to the nearest tenth. So do that and then come back. Okay, so hopefully you got a sum of 1720, 1720, divided that by 19, so you got approximately 90.5% for your average. So that's about a B plus, would be a good summary grade for this whole class. Okay, now the median, this, remember, is our middle number, and since there are 19 values, which is an odd number, do you think we'll have two numbers in the middle or just one? Hopefully you said just one because there's an odd number. So the first thing we need to do to figure out what the middle number is put these in order from least to greatest. So why don't we jot down underneath, let's make our list underneath here and fill in the numbers from smallest to largest. So make sure you check everything off and you've got everything in there. If a number repeats more than once, you need to write it as many times as it's there. So pause again, go ahead and put your numbers in order and see if you can figure out which one is in the middle. I'll be back in a second. Okay, so check your list with my list and make sure that you have everything there. You make sure you have 19 values and everything's in the correct order. And then you can start pairing up. And the way I do mine is I start at one end and I just put my pencil on one end and my finger on the other. And I partner them up until I get to the two in the middle or the one that doesn't have a partner in the middle. So I'll partner these two up and these two and these two. You can't see my finger, but my finger is moving along the left-hand side. So on, so on, so on, so on, and boom. So that first 92 is our middle number, and that's our median. Okay, mode, remember that is the most frequent number. So there were a couple numbers that were listed more than once. I know 86 was listed 3 times, 90 was 2, 92 was 3 times, and 100 was 2. So our top two were the 86 and 92 because they were each listed 3 times apiece. So that's the highest number of times they were listed. So this has two modes. And since it has two modes, it's called bimodal. Just like a bicycle has two wheels. Okay, now there's another term that we have to consider here. It's called an outlier. An outlier is a value that's either extremely high or extremely low compared to the rest of the data. So it kind of just doesn't really fit. It sticks out like a sore thumb. So in this case, would you say this has an outlier? And if so, what do you think it is? So look at your values. Our bottom number is 40. Our top number is 105. And then if you look at the numbers in between, the next number up is 83. So there's like a gap of 43 between the lowest and the second lowest. Up here, there's only a gap of 2 between our two highest numbers. So of those two, I would say that yes, there is an outlier. That 40 doesn't fit very well. So 40 would be our outlier. Now, because we have this really low grade, that's going to drag our average down because one low score is, it skews, is what it's called. It skews the information or skews the data, S-K-E-W-S. So in that case, sometimes we will take out the outlier, just kind of get rid of it while we use the rest of the data to get maybe a little bit better picture of what's happening here. So what would happen if the outlier was taken out of the data set? How would each measure of central tendency be affected? So let's show our work below and then fill in the table. So if we go up here, remember when I said to write down your sum? Well, this is the reason right here. If we have an outlier and I want to get rid of it, then I don't have to go back and add up all these numbers again. All I have to do is go to my sum and make it 40 less than it was. I want to take out 40 from this. So that means my new sum will be 1680. And then instead of dividing by 19 numbers, I'm dividing by 18. So if you divide 1680 by 18, you get about 93.3%. So you can see that our average went up from a B plus to an A minus. So it went up almost 3 points. So I'm going to say it increased, went up. Okay, now the median. So we're going to take out, remember we're taking out that 40. So we're going to start counting in on your median. Count in, count in, count in, count in. Keep going, keep going, keep going. And it turns out that these two 92s are sitting exactly in the middle. Now, since they're both in the middle, um, it's going to be pretty obvious that the median is still going to be 92, but we're taking the average of those two. So whatever those numbers happen to be, add them up, divide by 2, and in this case we'll get a 92%. I want to point out though that this 92% that's the actual median is not either one of these two data values. It's the average of the two. So it's a whole new 92 in this case. So there'll be other examples. So it did not change. It stayed the same. So that outlier had no effect on our median. And then there's the mode. Same thing. Look at if we take out 40, that's not going to change either of these two numbers that were most frequent. So 86 and 92 are still our modes. So we'll say they stayed the same too. So no change. You could write no change if you wanted. They stayed the same. Okay, last little piece of information. This is an easy one, so don't stress out. The range. The range is the difference, keyword, I'm a keyword, between the greatest value and the least value. So if you look at your highest number and your lowest number, it's very nice and easy to find once you put them in order. Oh. And then we find how big is the gap? What is the difference? Well, think, what operation do you think goes along with the word difference to find the range? And I'm hoping you just said to yourself, subtraction, because you are correct. The answer to a subtraction problem is the difference. So let's figure out what is the range of these data values, including the outlier. So if you remember, we're just going to take our highest minus our lowest is really all you're doing to find the home on the range. Highest minus lowest, our highest was 105. Our lowest with the outlier was 40. So that means we had a range of 65. That tells us that if we considered all the data, there is a wide span of grades. So a 65, that's a pretty big number considering your test scores usually go up to only about 100. In this case, it was 105 because there was a bonus point. Now, what if we took out the outlier? Well, then it would be 105 minus our next highest value, which was 83, and that gives us a range of 22. Now, what that tells us is that most of the data is clustered together. They're pretty close together. There's not a big span of grades. But what that does not tell us, if we didn't know all of the data and we just said, well, there's a range of 22, then we can conclude that they're all pretty well packed together, but you can't necessarily say if the grades were good or if they were bad. I mean, it would be great if the highest score was 100, and then your lowest score was 22 points below that, or in this case 105, and then 22 points below that. That's good. But what if the highest score was a 62 and then your lowest score was a 40? Your range would still be 22, but everybody failed. So in that case, that's not a good data set, but you can't conclude that from that number without knowing what the actual data values are. So just based on that information, we don't necessarily gain a good picture of what's happening with those test scores. So there you have it. That's central tendency, mean, median, and mode in a nutshell. I did this much faster the second time than the first time. Well, the first time there was a fire drill when I was recording, so who knows? But I'm okay. Don't worry. I got out of the building safely, as I'm sure all of you did too. All right, so there it is. Here's what you need to do. The next page, if you go back to your Moodle page, you need to print out this paper. It says Measures of Central Tendency. Use the table on the left, answer the questions on the right. Make sure you show your work wherever necessary. And don't be shy with those numbers. And you can use your calculator on that. And as soon as you get that done, you will need to turn it into me. All right, there it is. Enjoy. Talk to you later. Bye bye.